obviously one of the most important first things to do is figure out what some of the words I'm going to be using all year really mean, how they are the same, how they are different. For example, you've heard the word data for probably since you were in middle school. But what is data? Any ideas? Because it kind of helps if you can define it on your own. Now remember, when I show you the definition, you don't have to write it down verbatim. I'm never going to make you do that. Write down what makes sense to you. Yeah. Okay, information not necessarily given, but information that's coming from either observations, you counted it, you measured it, or even responses. What do they mean by responses there? What could that mean? Kind of a weird word to have in there, isn't it? Responses? Yeah. Yeah, a survey is probably your #1 place for responses to something. Like you ask them a question, what's the response? Yes, no. Just for your information, you don't have to write it down, but the singular form of data is datum. Okay. And you may have never heard that particular word before. Most people kind of think of it as data as both singular and plural, but data actually means more than one. So again, maybe you just wrote down information we collect or something like that. If that makes sense to you, good enough. You know? Questions on that? Well, let's just get that one out of the way. Statistics is basically the science. And so you're wondering, why is this a math class if the word science is in there? But the actual statistics is a science of collecting that, organizing it, analyzing it, and then interpreting it. It kind of does go in that order. You collect the information first, you organize it somehow, so that normally it's in numerical order, but you organize it somehow. Then you analyze it, you look at it. That's what most of this class is the analyzing and interpreting. Believe it or not, you've done the first two a lot already, collecting and organizing. You know, histograms, stem and leaf plots, all that stuff, that's the organizing. Okay. Analyzing and interpreting is what we're going to do in here. And hopefully we can have some fun with that. Pull some stuff that's current, see if it's any good. You look at newspapers, see if they're trying to trick you. Because that's the one thing about stats. You can kind of make it say whatever you want to depending on how you skew things. Population. What's that? Just in general, what's population mean?
People in an area.
People in an area, yeah. That's kind of is really good. Population in stats basically means the collection, you might notice I highlighted a word there. Collection of all outcomes, responses, measurements, or counts. So you could just basically say all possibilities would be a nice simple way of shortening that up. All possibilities of what could happen. And the difference between population and sample is going to be huge. Knowing the difference. Let's just put it this way. To do a population is often fairly difficult. To get everything, or to ask everybody that question, is very difficult. Unless you can narrow it down somehow. At least population's hard for a big pool. Sample, a very simple one, is a subset of a population. For example, you in this class are a subset of the population of this high school. You're a smaller group of everybody. And what you're going to find in stats, a lot of times it's easier to just take a sample. For example, if I wanted to know what this high school thought about a certain topic, obviously in this high school, could I ask the population? Could I ask every single student? I probably could. What if you're in, say, Madison? Is it very feasible to ask every single student that question? No, you're just going to take a sample. You're going to take this group over here, but you got to make sure your sample's good. It has to be diverse. Okay? If your sample's good, then the information you get from that's going to be good. Okay? Kind of think of all this politics we've been dealing with lately, all these surveys, they say, all these polls. Sometimes their polls are not very good samples. They call houses they know are going to answer the way they want it to be answered. Okay, so that's where you have to watch out. So any problems with the difference between population and sample? If I just said the population of this class, very small. Okay, population of Wisconsin, very big. Okay. Questions so far? No? Well, let's make sure here. So it says here, example 1, in a recent survey, 3,002 American adults were asked if they read news on the internet at least once a week. Because let's face it, a lot of people are starting to get their information. They don't even watch the nightly news anymore. They just bring up the computer in the morning and read it on there, right? At least once a week, though, they're saying here. So 600 of the adults said yes. It's going to be very interesting to see what you say for these answers. I think the first one is the easiest one to get wrong. What is the population? Very easy to get this wrong. Paul? American adults. Just the 3,002 of them? No, all of them. Very good. That's perfect. I was worried about that one, but that's perfect. All American adults is the population. Okay. So in this one, the sample, just some of them, right? Sample is just a subset of it. This sample seems big to you. I know. 3,002 seems like a lot of people, right? But as far as its percentage of the actual population, is that a whole lot? Not really. But if it's a good sample, could you still get accurate information? You could. And that's something we're going to learn this year. How big does it have to be for you to get a good sample? That's stuff we're going to figure out. Okay? So the sample here is, I think most of you probably got it figured out by now, the 3,002 American adults that they talked to. Did I spell that right? This looked wrong. This is something we haven't talked about yet. It wasn't in there because I figured this question would figure it out and then help you with that. What does the data set consist of? So basically, what data are we getting? We're getting an answer to a question, correct? And there's only two answers to this particular question. It's either yes or no, right? That's the only two answers that's the data we're going to get, is a yes or no, and we're going to have to tally that, right? And in fact, we already know the tally of this. We know that 600 said, so we know that the data set is 600 yes, but that's not all the data we're going to get, is it? It's very possible that the first 600 could have said yes. Okay, but we didn't just ask that many people. We asked 3,002. So what else is in our data set? A whole lot of no's, and how many no's are we looking at? This is the data that we would have gotten. Yep. Now it's way easier than just saying, here's one yes, two yeses, right? We just say how many we had. There's no maybes in there. There's no Wyoming in the data set here. They're not going to answer that. All right? That's not in our data. Or Montana. Or 0, right? That's not in our data. That's not something we got. Okay? It was yes or no, flat out. That's the way it was answered. Let's say a lot of questions you ask have option A, B, C, a lot of those, but that's not what we had here. Okay? So any question between population, sample, now this is kind of a new one, data set. What's in your data? Is it possible one person out there was being weird and answered something weird? Well, yeah, but we don't know that from this problem. Okay? If you're doing good so far, if you get these next two, I think you're going to be all right. And I'm going to give you a memory device to figure it out. Question or no? Okay. Parameter and statistic. Now you might notice, didn't we already define statistic? Well, no, we defined statistics as a science. This is a statistic. Okay? Parameter. Think you know? Kind of. It's what's going to happen here is it depends on where we take it from is really the difference between these two words. It's a very easy mnemonic device, and we'll see if you can come up with it. This parameter is basically some kind of data or a numerical description, like the 600. That's a numerical description of a population characteristic. But it has to be from the population. Are we always going to have the population? No. Very infrequently will we have a parameter. Again, these two words are very closely related. So parameter is basically from the population. Very good. The other one's the exact same thing, but from the sample. Exactly. That's what a statistic is. It's a numerical description of a sample. And whatever the characteristic is, we don't know. Could be the answer they gave. Could be whatever. We can use a statistic or a bunch of data to try and figure out what a parameter might be, but unless we have the whole population, no. Anybody see a nice, easy mnemonic device on this one?
PPSS.
Yeah, PPSS. Population is parameter, right? Statistic is sample. Very simple. Okay. And these are the things that I'm trying to push on you for when you go on to school. Find stuff like this, because they might not give that to you. They might not, oh, here's an easy way to remember that. They might not say that. Because I just took some classes this summer, and that was just like, go. And he was gone. Took off. If you were lost, it was your problem, not his. Well, for a short period in one of them, yes. But that was an abstract algebra. That was a very bizarre class. It seemed like you could just make up whatever you wanted to, and it was okay. It's okay. So let's try this. A recent survey of a sample of MBAs reported that the average starting salary for an MBA is less than $65,000. There is a numerical value there. Do you agree? Okay. Does it describe a population parameter or a sample statistic? Why is it a sample? Sample statistic. Oh, sample of MBA. So it's not all the MBAs, correct? So you're right. In this case, that 65,000 is basically a sample statistic. You see what it means? How it's a numerical characteristic here. It's a 65. It's a number. It's either less than that, more than that. That's the characteristic we're talking about. We're kind of comparing, right? So that's a sample statistic. So now let's make it a little harder on you. How could you change this problem to make it a population parameter? Yeah. Yeah, of all, right? Just say of all MBAs reported that, and does that make it a population parameter? Just flat out. It does, correct? Then you have to sometimes stop, though. She's correct. Is that feasible? All MBAs? A lot of people, right? Okay, and so that's where you have to look back and forth. Do we want a population parameter? That's what you want. You want to know exactly how it is, but sometimes you can't, and that's where the science of statistics comes in. You take a sample and do the best you can. Okay, that's the whole difference as to basically what we're going to be doing. So perfect. Good job. Or one other way you could have done it is said, surveyed the MBAs from UW Oshkosh. Could I survey all of them? Could I survey that population? That I could probably do. But of all, that's pretty tough. But there you go. You're doing good. Descriptive statistics and inferential statistics. We're almost done. Probably no assignment today. Well, what's the word descriptive mean? Detail. You want to use the word describe, right? Yeah. I mean, let's face it, that's the word we want to use. It's in there. Descriptive. Right? Again, paraphrase this stuff. Don't write it all down. The branch of statistics, so it's part of statistics that involves organizing, summation, and display of the data because it's describing the data. So that's your stem and leaf. That's your mocks and whiskers, your histogram, with those frequency tables with all those X's you used to put down. Remember those? I mean, that's organizing data. You might not have thought of it that way before, but you were or summarizing it or displaying it. That's what you were doing. Again, that's kind of the first two steps of statistics that you've already kind of done. You've collected it and you've organized it. You've done that. So that's one I don't think we're going to have to teach a ton on. It's the next one that we're probably going to have to talk about a lot. And that's really where we want to go with this. This is the power of stats. Inferential. Inferential, what word do you see in there? Infer. Well, what does that mean? What you gather from what you know. I think, didn't somebody say like a guess? Didn't somebody say that? Not just a guess, but an educated, very educated guess as to what's going to happen for that population. Okay? Because let's face it, we're not always going to know. So yeah, that's perfect. I mean, you don't have to, if you want to write down a guess or something, that's fine. So this is obviously part of stats that involves using that sample to get a conclusion about the population. Getting that guess, what's going to happen, what is that parameter, you know, what is that population, what's going to happen, or getting that, yeah, I guess guess is a pretty good word, or educated guess. And if you start reading example 3, I actually did get this stat from somewhere, but can't remember where. I should probably cite it, but I can't remember where I got it from. As you read it, was there anything inferred in this? Did they infer anything as you read it? No, they're just basically telling us this is what we came up with, right? They're not saying, well, we think this is what that means, or we think this, or this might happen. They're flat out saying, so basically, some of your descriptive statistics are going to be, there's one. So unmarried meds, 60 to 70% were alive at age 65. That is flat out descriptive. That's telling you what they had. Okay, because they organized it, and that's what it said. 60 to 70% were alive at that age. That's why this is actually a stat I got from somewhere, and that's kind of what I was thinking too. I'm surprised it wasn't the other way around. This is going to be too dark, isn't it? Well, you got to get the idea. Is that descriptive? Is that inferred? That's terrible. We got to get rid of that. Descriptive or inferred? Descriptive is just telling you. That's what it was. Let's go with like a green one there. Okay. You know, like some of you said, I kind of expected that to be the other way around. But yeah, I think that's why I used this particular one. Yeah, that's descriptive. There you go. Those two things are descriptive. Now, right here, it's telling you to make an inference. Okay, that's inferential. So based on what you've read, there's obviously a lot of inferences you could make, but the most logical one is that, well, married men live longer. Is that necessarily true? Well, this is just a study somebody did. Do we know how accurate their study was? No. Right, that's an inference. Do we know our inference is correct? No, but it is an inference. So you see, don't think just because that study could have been terrible. Does it say they were even drawn from the same country? No. They could have gone completely somewhere else for the married men. And then they could have done this one in maybe a bad neighborhood, or, you know, they don't say that. So do you see how this, who knows, maybe it actually is overall the other way around. So that's where you have to watch out for stats. Is it a trusted source? Do they specify where it came from? And that's what I mean. You can make it say whatever you want. Your job, if you want to be a statistician, is to flat out make it as accurate as you can. Okay? I'm going to show you something in a couple days, and then throughout the year we're going to kind of work on that and see if they do a good job. Because they've kind of come under fire recently for how they do things. So we'll see what you think by the end of the year. Okay, and I want you to make your own decision. I don't want to lead you one way or the other. We'll just do the math and see what happens. Okay? So any questions on any of that? I know it's a lot of words for the first day, but I'd say about half the words you have at least seen before or knew the root of the word. Correct? Okay?